Hello everyone, welcome to Pepcoding. Today we are here to solve a question named remove node in Doubly linked list. Okay, so in this question what we have to do, we are given a reference node and we have to delete that specific node from the given linked list. Okay, previously also we have solved the question remove node that was using index. Okay, but now we are given the reference node that we have to delete. So let's go and have a look on the code. Here are some partially written Doubly linked list class and there are some functions. We have add functions and all. Let's find the function that we have to complete. Okay, so it is here somewhere. Okay, this is remove node. Okay, here we are given a reference node. We have to complete this function. What it will work, it will simply remove the node that is given to us. Okay, so let's move towards the board now and discuss the question. After that we will look for the solution. So this is the board. Just suppose this is the given doubly linked list we have. Okay, so there are many cases that we have to think of when we talk about removing the node from the doubly linked list. So the first case sorry, that come in my mind is, just suppose we are having just one node in the doubly linked list. So our head is also pointing to it and tail is also pointing to the same node. Just suppose its value is 6. Okay, so after this what will happen if we have to remove this? So after that our head will also point to null and tail will also point to null. This will happen. Okay, now let's move forward. This is the first case. Now just make a list what cases we have, so it will be pretty easy to handle. Okay, if the size is equals to 1 of the W linked list, sorry, so this is the first case. Now let's talk about the second case. What will be the second case? Just suppose if the node that we have to delete is the head of this doubly linked list, so it will be here, and what we will do, we will shift our head to the next to delete this node, but this node is still not deleted, it is connected to it somehow. We have to break this loop. We will find out how. Okay, so this is the second case. If the reference node is equals to head of the doubly linked list. Now let's move forward and talk about the third case that we need to handle. Okay, same like this one, we also have a case like if we have to delete the last node, that is the tail of that doubly linked list. If we have to delete the tail node, what we have to do, we have to shift the tail to the previous one, right? So the third case arises that if our reference node is equals to the tail. This is third case. After handling all these three cases, we are left with this range, right? So for checking that the reference node is head, first option we have is to directly check it with the head, and the second option that will help us also to solve this part. That's why I am telling you this method, that if we find out the previous of reference node, the previous of reference node is null, it means it is the head, because only the head have the previous as null. So if it's the reference node previous is null, it means the reference node is head. And the second case, if the next of reference node is null, it means it is the tail. So we calculated it just by using the reference node. Okay, this method help us solving this part also. That's why I am telling you this method to check out if it is head or not. Okay, so we have discussed three methods till now. Now let's just move towards the editor and write this much as we have discussed. After that we'll come back and look something for this part. So we are here, let's go on the full screen and here. So first of all we need the previous and the next node of the given reference node. So for that what we'll do, we'll make a node as previous, which will be equals to reference node previous, and one more node we have to make, that will be forward. What it will store, it will store the next of the reference node. So reference node next. This is done. These two things are done. After this what we have to do, we have to start handling our cases. First case was sorry, if the size is equals to 1. So let's go and handle that. If if the size is equals to 1. What it means? It means it have only one node present. Okay, actually why don't this question comes in your mind? Maybe it don't have any node. Actually this case can't be here because we are given one reference node to delete, right? So this node is present inside this given doubly linked list, so it can't be possible that uh, the linked list is empty. Okay, that's why we haven't handled that case. So we are here, and what we have to do here, if the size equals to 0, we have to point the head and tail to the null. Okay, so if this is the case, this dot head will be equals to this dot tail, and it will both point to the null. Okay, this is done. Now let's move towards the second case. Else if the what we have, let's go and see. The reference node is head. If the reference node is equals to head, what is the condition to check that? Our previous will be equals to the null. Okay, so if our previous is equals to null, it means it is head. So what was the method to remove the head, like to remove the node if it is head? So we just shift the head by 1. So head will be equals to next. Okay, so it is shifted by 1, so it is clear that the head is shifted to one step ahead. So now our head is here. Okay, now we have to take care of this case. If the reference node is tail, what we do, we send back the tail to one step back. Okay, so how we are going to check that if it is the tail? Very simple. If the forward node is equals to null pointer, okay, here we have written null, but it will be null pointer, so it means it is a tail. Okay, so if it is a tail, so this dot tail equals to this tail previous, right? So tail is shifted one step back. Okay, now the else condition for the rest of the element for this range from here to here. Okay, there are some more things we have to take care of, like our head is shifted to this point, but still this link is attached, right? So if someone find this node, he will get all of our data. So we have to break this loop also. Just by shifting head it won't work. We have to delete this link. Okay, we will do it later, but first of all let's go with the flow. Let's decide what we have to do with this nodes if we have to delete some node from here. So let's discuss how we are going to do that. So this is the range that we have. Just suppose now we have to delete this node. Okay, this is our reference node, so this will be our previous node and this will be our forward node, right? Okay, so if we have to delete this node, so the next of the previous should be equals to forward, right? And the previous of this forward should be equals to the previous. Exactly. So let's go and implement this inside our code. So we are here now. So what we have to do, the next of the previous will be equals to forward, and the previous of forward previous will be equals to previous, right? These two things are done here. Okay, right? So if we have done that, what it means, it means this link is broken and this link is broken, but still somehow it is connected to these links, these lists. Okay, so we have to break these links also. So just consider one thing, every time if we are removing a node, its next and previous should be null. Every time it will be removed, every time. It is common for all the cases that we have studied here. Okay, the next and previous of the reference node should be equals to null. So this is one case, and this will be same for all the other. Like here when we're talking about the head, if our reference node is head, we still have to remove the next and the previous of the reference node. Okay. And one more thing, if the case is about head, the previous of head always equals to null. It doesn't point any other node. It is always equals to null. And the same case with the tail also, the next of the tail is always equals to null. Okay. So if our tail shifted to this point, what will happen? This is still pointing to this node, but we have to remove this also. This will also go to the null. Okay. And the node dot previous also equals to null. So this node will be deleted. So all this is common for all the cases. So we will write it here. Right. So now this dot head that previous will be equals to null, and this tail next will also be equals to null, right? And reference node next will be also equals to null, right? And reference node previous will also be equals to null, right? Let's move and make it null pointer. We have handled all that just in one line, right? So this is done. Now where we are heading, just suppose removed the node, this node is removed. Now don't you think that size of this list is reduced? Just suppose, first of all, we have 1 2 3 4 5 and 6 node, but this node is not now in this list. So 4 is removed. 1 2 3 4 and 5 is the size of this list. So we have to reduce the size also. So this size minus minus. Now the size is also done. After this, what you have to do? You have to return the data of the reference node that we have deleted. So return reference node data. Okay, this is done. Now let's go. This is all that we have to take care of. This is all that we have planned. Now just go and run this code. So we are here. We have run this code. It is accepted. Now let's submit this code. Okay, correct, 10 by 10. So I hope you have learned something. So I just have a question in mind. Just suppose if this same question was given in the single linked list, do you really think it is that easy to do? I don't think so. Just give it a thought. Okay, bye bye, take care. I hope you have liked the video till now. Please like and share the video and subscribe the channel. Thank you so much.